Any volunteer? Leaders now. Okay. Yes, Matthias.
Um, Lord, our loving Father, we thank you for the gift of life. We thank you for the gift of this day. As we are going to encounter this lesson of math, we pray that whatever we are going to learn from here today, we can grasp it, put it into mind and practice so that we can achieve our goals. For this we pray.
And thank you so much. Allow me to mute everyone such that we do not have any noise. And so in case we have anything, Ruth will be able to help out to unmute you and for any contribution, but we shall be using the chat. Those who are having their videos on, you may consider having them
I'm
off.
going to disable that setting.
Okay. Yeah, such that we can reduce on the data bundles you are using. Yeah. So today we are going to be looking at this topic of math. But I'll tell you when to write. So there is no need for you to write now until when I tell you to start the writing. So like I think other teachers have been telling you, we have started on the form for work such that you can be on an advantage by second term to be through with the syllabus of math, such that when you come back for second term holiday, we are just having a revision and getting ready for the final exams. So we are going to start with a simple activity, displaying some photos, and afterwards I'll ask you some questions will pop up. So just look at what is being displayed and then get ready to use the chat to answer the questions. Those are we shall be using. So I'm displaying some photos. Those are the photos. So we are going to use the chat. I'm asking the first question. The first question is there. So kindly use the chat to identify. Don't mind about the order. For you just identify all the items in the picture. What are you observing from the pictures that are being displayed? So just put your answers in the chat on what you are seeing.
Okay, in the chat, there is not, I've not yet received anything as yet.
Yeah, I'm seeing some things coming up. I'm
Mhm.
seeing tablets,
Okay.
sugarcane, drugs, sugarcane, sweet, drugs, sugarcane, medicine, sugarcane, sugarcane juice. Oh, someone is saying rice. Someone is saying rice, drugs, sugarcane. Okay, sugarcane crystals. Okay, I think we're on track. Hope they have appeared on your end. Okay, sugarcane plantation, sugar fruits and juice, sugar crystals, sugar candies, and then the tablets, juice, sugar, tablets, sugar. Okay, sweets. Okay, someone has been able to identify those sweets, products from sugar. Okay, very good. Okay, that is good. Another question is coming up. Yes, for this one, you can raise up the hand and you tell us. Raise up your hand and you tell us. There is that question that has appeared. Is there any relation that exists between the items named from the picture? Okay. Okay, Matthias.
Sir, the relation which I'm seeing, I'm seeing the products which are made from sugarcane plantation. I'm seeing here sugar, and then also I'm seeing some sweets, because some sweets are also made from the same stuffs of sugarcane. Yes, I'm seeing the relation of, I think it's, yeah, that's the relation I'm seeing.
Okay, thank you so much. Saying Deo Gracias. Vanessa.
Okay, so for me, the relation is they are all eaten. They're good for human consumption.
Okay, thank you so much. I'm saying Bridget. Oh, Bridget is not unmuting. Bakita.
Sir,
Yes.
me the relation I'm seeing, those products they all contain sugar in them.
Okay, thank you so much. You are
Welcome.
correct also. Alan.
Teacher, for me, what I see, all that they are manufactured from sugar.
Okay, all of them are manufactured from sugar. And which items are those?
The sweets, the sugarcane juice, and some tablets.
Okay, thank you. Okay, Bakita, you are the last.
Okay, so the relationship I see is they all share one raw material.
Okay, very good. And which raw material is that?
The sugarcane plant.
Okay, the sugarcane plant. Okay, good. Another question is coming up. Okay, Bridget, you want to be the first? Which of the pictures show a multiple change process? Yes, Bridget, at Christ. Bridget is not. Okay, Sharia.
The bugs and sweets, and also maybe the sugar crystals, because they are literally transformed their form to something really different from sugar.
Okay, thank you. Okay, I'm saying another hand. Allen.
Yeah, for me, I think so that sweet.
Okay. And your explanation?
Because sweets in by the big teachers so much.
Okay, okay. Then lastly, Techno, come on. I don't know whether you can rename yourself. Tracy?
Me,
Yes?
I say sweets. Are you hearing me?
Yes, continue.
I say sweets. Have you heard me?
Yes, why?
I say sweets because before they reach to the end process of making them, they are passed through many processes like grinding the sugar into crystals, then the crystals are dried like that.
Okay, very good. Okay, I think those are enough. Those are enough. So we can continue. Now, when you look at the pictures that we have been seeing, there was some medicine, like what people mentioned, but also we had some sweets. And you know very that in order for us to make sweets, you need to have the sugar, and for some tablets, they're always coated. Yes, you have seen medicine that they coat, most so when it is very bitter, they usually coat it with sugar in order for it to become a bit tasty. So also it is used in the tablets. So which multiple change process occur? We have sugarcane processed into sugar, and then from sugar, you end up getting the what? The sweets. The same thing happens when you have the sugarcane, you go to sugar and you go to medicine. So all those people who are mentioning sweets, who are mentioning the medicine, you were very correct. So those are the products that undergo multiple change process. And now that multiple change process in math is what we call composite functions. So when you look at this scenario, or when you look at the process that sweets go through two major processes. The first one, here there is a function. So this is what we are going to call in mathematics. So from sugarcane to sugar, that is one product. So then from sugarcane to sweets, it undergoes another process. So here there is sugar production, and then we shall have the sweet production. So this is the first function, and then this is the second function. So having two functions in the same process, we shall be calling it a composite function. And therefore, in this topic, we are going to be looking at what we call composite functions. So composite functions means that two or more processes are taking place in the same value chain. That as they are making sweets, there are other processes that occur during the manufacturing of the sweets. So the first process, we have said that when you are manufacturing sugar from sugarcane, you have to put the sugar canes into the machine. So that is the first function that will be performed. So the sugar canes will be broken and the juice will be extracted. After the juice has been extracted, and then we can also have another process of converting that juice into the crystals. And then from those crystals, we can go on and manufacture the sweets. So those multiple kind of processes are what we shall be calling composite functions. And therefore, the topic that we are going to look at is going to involve such processes whereby we are going to combine more than one function in order for us to obtain. So when you look at the picture on my screen, I was here showing you the multiple processes that sugar undergoes before we make or we obtain the sweets. So here you can see that these are our sugar canes. They pass them through the machine in order for them to get the sugar. And then the sugar is also pass through the machine to come up with the sweets. So we have two different machines, and each of those machines performing a different functions. So having two functions being combined is what we call composite functions. So our topic today is called composite functions. So you can now write what we call composite functions as your new topic for today. So you can first write that in your books. Okay, hope people have finished. Yes, yes, Rodney, we can have even 3 functions, but 3 functions, they will be at a higher level. Yes, 3 functions, they will be at a higher level. Yes, so we shall meet them, but at that higher level. Yes, Allen, I'm seeing your hand up. Any question?
Master, that I've not understood that what you were saying, as in the topic.
The topic. Oh, we are
Ye-
starting, and we are saying the topic is called composite functions. And I was explaining to you what we call composite functions. And we said that composite functions means going through processes, that from one process, you go to another process before you get to the finished product. Like you have seen things, let me say, I was talking about sweets, that in order for you to go to manufacture a sweet, there are very many processes that occur. First, you have to get the sugar canes. From sugar canes, you have to get sugar. So that is one function the machine is going to do. Then when that machine finishes to process the sugar, then you have to get that sugar, grind it, smoothen it, such that you can come up with the sweets. So that is another function. So composite means you have more than 2 functions being performed by the machine. So they can be different. Yes. So we have different machines and each of them is performing its own duty. So one is responsible for extracting sugar. Another one is for grinding the sugar. Another one is for doing this and the other. So we are going to look at different functions combined.
Thank you, teacher.
Okay. Now there is a quick puzzle here. Quick puzzle we shall give, I'm going to allow people to annotate. But you first raise up your hand, and then you are going to identify for us. This one is for people who can look at it very quickly. Yes, those who can annotate, and look for us the words you are seeing. Feel free to annotate. We are looking for the word inverse. We are looking for the word mapping, domain, range, composite, graphical table notation. Right on the screen. Very good, Alice Favor. Yes, Alice Favor has identified one. Yes. You can write on the screen. Identify. Brian has identified. Bridget, Alice Favor. I've seen Nicole. Good. Okay. Yes, I've seen Nola. I've seen Patience. Okay, yes, Zuena. Yes, something like that. Okay, Sylvia. Okay, okay. That is good. Praise. Okay. I'm saying Masa. Okay, good. Yes. Can we now put those keywords in our books? Some of the keywords in this topic. So those are some of the keywords. Put them in your book. Yes, Favor. Favor.
No, I just left my hand up, sorry.
Oh, okay. Okay. Yes, Bridget. Okay, so those are some of the words. Let me hope people have seen them. So those are some of the words that are going to be common. You are going to hear the word mapping, the word inverse, domain, range, composite functions, notation. So those are some of the words that we are going to be interacting with. Okay, I think we can go on. Okay, so those who fail to identify those keywords, you can look there. Those words are there. So the words that we shall be looking at. Okay, we can continue. And therefore, what are our learning objectives by the end of this lesson? The first learning objective is that everyone must be able to understand and use what we call function notation. And our second objective for the lesson is that by the end of this lesson, everyone must be able to describe and understand what we call a composite function. I do understand that earlier on.
Mr. Kaziba,
Yes.
am I clear?
Yes, you are clear.
Is Alan, is your hand up? Seems like you're also unmuted. Did you have anything to say? Alan? Sorry for interruption.
Okay, I think maybe she forgot the hand. Okay. Okay, so those are the two learning outcomes that we are going to achieve in this lesson. So I can continue. Now, when you look at the screen, we are going to first look at what we call a function notation. When we talk about a function notation, we are looking at how do we write a function? Through the chat, let me check those people who talked about functions in senior 2 in the topic of mappings and relations. Write in the chat an example of a function or how you wrote a function in mathematically using symbols. Just type in the chat how you remember, or which letters do you know that represent a function? How did you write it? So feel free to type in the chat. I'm waiting to see the answer. Zero is saying F of G of F of X, good. F, yes. Then that is very good. G, yes, good. F, yes. F, yes. So those are the common letters we use. When we are denoting a function, we always use F. But those who are writing capital letters, we always use a small letter. Much as you can use a capital letter, depending on how you have defined it, but we always use a small letter. The common letters we shall be using, we shall use the letter F. So when you find F in math, that F is standing in for what you call a function. When you find F, when you find G, at times they use H. These are the common letters we use when we are representing a function. And you know that a function is like the process that occurs, what a machine does. Take an example. When you have, this is our machine inside here. Let me use a simple machine. This is our machine. Those people who grow maize at home, you know very well that when they bring that machine at home and they put maize inside, at the output here, you'll be able to see the maize grains. When you look at the calculator, the calculators we are having, in a calc, you are going to have one, we have what we call an input. An input is what you insert. Take an example, you can put 1 plus 2. That is the input. Then inside, the calculator is going to perform a function. Now, in case there's a calculator here, the calculator is going to add. And then at the end, it's going to give you an output. And this output is the result you get. So the calculator will do the function, will do the processor, and then to give you your answers 3. So for any function, it has something it does. It can be a function may be adding, may be subtracting, may be multiplying, it can be dividing. In real life, it can be something that breaks something. Take an example, you have seen those machines that go on and their work is to break something into small particles. So a function, it can be anything in real life. But in math, our function, we shall be sticking to particular things that are either adding, subtracting, division, multiplication, obtaining square roots. So those are some of the operations and the functions that the machines we are going to deal with, they will be doing. Okay, So I'm going to ask you to first summarize. Yes. So summarize. So when you find fx, this one we read it mathematically as f of x, and means the value of the function f at x. So I'm going to give you some minutes to summarize. Summarize what you are seeing on the screen. Write out the key points you need to know about a function. You don't need to write everything, for you just pick out a few things that you need. When you finish to summarize, let me know. Okay. Okay. So as people are summarizing, I can throw more light. And now, like we have said, a function notation means noting something down. How do you write something down? That's what you call a function notation. And in math, like I've told you, a
Mr.
function.
Kaziba,
Yes.
sorry for interrupting again, as you also throw more light. I don't know whether you've seen this question in the chat from Tarema Rodney. It says, what of G? Can we use other letters?
Oh, yes, it is very fine.
Okay.
So, when you are noting a function, feel free to use F, feel free to use G, feel free to use H, feel free to use M, use any letter. Any letter can represent a function. But why is F very common? Because it brings out the word function. So when someone sees F, he can easily relate that that is a function. But in books, you're going to find F, you're going to find G, you shall find H. But however, some of the common letters that we don't use, one of those letters, we cannot use X to represent a function. So this one will look ugly and it will confuse you because always in the function, we have to feed in something. We have to put in some values. And and all times, we always put in the x values. When you want to understand what you call, so like we have said, so you can write g of x. You can have h of x. And what does it mean? It means that in our function, we are putting in x. That's what we are feeding in. When I write h and I put here y, it means that in our function, we are feeding in y. Like you have noticed when we are looking at the sugar canes, that inside the machine, in order for us to be able to produce the sweets, we had to bring sugar and put it into the machine. Then the machine processes, it grinds it, and then you get the what? The sweets. So here, your function is this machine here, is what the machine is doing to grind. And what you are putting inside the machine is the x. So what you put inside the machine to get a sweet is what we are calling the x. And what the machine does inside, that process that you do not see, the grinding of those sugar particles to form the fine sugar and other processes, is what we are calling the H. So H, G, and the rest, they are representing inside processes that occur when it comes to a machine. Then the answer you obtain when you have f of x is what we call the output. So in case we are comparing it to the sugar manufacturing of the sweets, what you get is the sweet, the output. So any answer you get from evaluating f of x is the sweet. X is the sugar you put into the machine. Then the whole of this process, F, is the process that occurs in order for you to produce the sweets. So you have said F, the function, refers to that process that occurs in order for you to come up with the sweets. Then X is what you put inside the machine, which is sugar. And what you get outside is the output, what we call the sweets. Okay. Tekno?
Yeah, so there is something I'm asking.
Yes.
Is what is in the brackets the function?
Yeah, like what? No, yes. So like the F and what you put inside, everything like represents now the whole process, what the machine is going to do after you have put the sugar.
Okay, thank you, sir.
Okay. Allen?
Teacher, I was inquiring about the weight, like in order like to what? To pair, like how can we pair them? Like as in when like we put an X, we open the brackets, then we put X, then afterwards we write the function, then afterwards we open, then we put the what? We put the X in the bracket, then afterwards they said that we close the brackets. What does it mean?
Okay, we are going to try out. We are going to try out some numbers, and you see how it works.
Okay, teacher.
Okay. Take note. Okay.
Sir, the equation part, that equation part.
Okay. Okay. I want to work out a number. I'm working out a number, and then you are going to see how it works.
Okay, sir.
Now, okay, lastly, Kathy. Kathy? Okay. Now, I think she was asking about this second format of writing a function. So now when you find something of this nature, 2x plus 1, this is the second way of writing a function. Now, what are they telling you? Like the first letter stands for the input. This arrow is the one that is representing the function that the machine is doing. And then the answer you have here is what we call like the output. So your function can either be written like this, or it can be written in the simple format. But what you need to know that a function, when you find f of x is the output, everything you get after doing some kind of task. Like when you put 2 times 2 in the calculator, 2 times 2 is the is the 2 and these 2 are like the x. Then inside the calculator is going to multiply, it does its thing, and then it will give you the output as 4. So all those processes that the calculators are doing is what we are referring as the functions that they carry. But mathematically, we represent it using f, we represent it using g, h, or any other letter. Kathy? I think I'm failing to get Kathy. We are going to continue. Like here, I told you, you just need to summarize, not everything here. You need it. Kathy?
Na atcha. Yogera. Ng'ambe. Twategedde wano. Sina nabyentegeera leero.
Okay. I think Kathy was wasting. So, okay. Now we are going to do an activity. I have an activity here. We have an activity here. And now this activity, I want everyone to first try it on your own. And then you can even put for us the answer in the chat. We have, this is our machine. We have, this is the input, and this is the output, and this is the function the machine is doing. So try out this activity. I did for you one, that when we put in 1, at the end we get 3. Can we quickly obtain the answer? Just put them in the chat, what you are getting. Okay, I think people are getting the answer. I'm seeing only correct answers. Unless there is someone, can we have just one person to just briefly take us through how you are getting the answer? Any person? Anyone? Just one. Okay. Sylvia?
Yes, thank you, teacher, for the lesson. You get the input, then you add the 2 to get the output. Here on 4, we are going to get the function, which is 2. We add it, then we get 6.
Okay. So here
Then we shall get 3. Then we add on the function, which is 2. Then with the answer will be 5. Here the input is 0. We add on the function, which is 2. Then we get the answer as 2. The last one, the input, which is 5. We add on the function, which is 2. Then we get 7.
Thank you so much. Okay,
You
this
are
is very
welcome.
good. Now, how are we going to write it? Now, this question, we can write it in case I want to use now using mathematical notation. How do I write it? In mathematical notation, I can use f. Then inside f, this is the function. Inside f, I'm going to put my input. So in case this is your input, you can call it any letter. Say I'm calling it x. So I will say x. That inside my function, I'm going to put x. So you are noticing that when I get our input is x, and now this x, when it comes inside, what does it do? It adds a 2. So in other words, my function is for any value of x that enters, add a 2. And now this is what we call the function notation. So instead of you receiving the question in this format, we are going to start getting it in this format, whereby you have your function, and inside your function, you put the value, which is x. So now this is the expression that is going to be yielding. Take an example. When x is 1, you'll come here and say f inside x, we are saying we are putting 1. And therefore, when you come to the function where there is x, you put 1. So I'll have 1 plus 2, which will give me a 3. Kindly let me know in the chat whether that step is okay. Say yes, that it is okay, we can continue. As Alan asks. Yes.
Excuse me, teacher.
Yes, please.
Thank you for that lesson. So, teacher, I was just inquiring that, is it a must that the rule has to be 2?
No. It can be anything. You may find others when it is multiplying, you can find when it is squaring, you can find. So it can be anything. Like you see the machines, you have phones that have different functions, or like the way you see apps, you have an app that can take photos, you have this one that does this. So each of them is having different functions.
Meaning, teacher, they can also give you that like x squared.
Exactly.
Okay. Thank you, teacher.
Okay. Yes, Joanne? Okay. So looking in the chat, people are saying yes, yes. Yes. Thank you, Fahad. Yeah. So for this particular one, our rule was addition, but it can differ. So depending on how the question is being said. Okay, we can now continue. We have an activity. Can we first try it? Let me allow it to unmute. Should we first try it together? Or we try it alone in our own books first.
Try it.
On your own, not so?
Yes.
Yes. First. Okay.
Now on books.
Yes, first try it. First try it.
Okay, yes.
Okay. So let me mute you to avoid the noise. Some of you like making noise. So try it in your book. When you finish, put your answer in the chat. Confidently. Just put your answer in the chat. In case you're having some challenges, don't worry. I know we are going to be on the same page.
Recording in progress.
Seeing very many answers in the chat. Wow, wow, wow. This is very good. Yeah, Lion King. Oh, Azi has just reached Loving Julia, The Gracious, Lion King, Patience, Bakita, Atapi, Allen, Infinite, Edith, Macho, Tendo, Divine. Okay, Ella, we are going to do taking, yeah, at least Kirabo part. Okay, good, good, good. This is really very nice, very nice. Yeah, 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 yeah. Good, 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 good. Okay, let me ask Guma. Guma, kindly unmute and take us through. I want someone now to take us through. Gabriel, is it possible? Okay. Who has not said anything?
Yes, teacher.
Okay, okay. You can start, no worries. Take us through part A.
Okay, in simple terms, all you have to do is replace the h into h of -4. So you get that -4 and replace it with the x. So it will be 6 times -4 plus 2. Then you get your answer.
So what is 6 times -4?
-24.
-24.
Plus 2, then you get -22.
Okay. Thank you, Gabriel. Okay. I have Buko done. Yes, Dan.
Yes. Okay, I would like to take you through number B. Open bracket whereby x you replace with 0. Multiply 6 times 2 as the answer. Then h function 0 is equal to 2.
Okay. Thank you. That is it. Then Linda.
So I'll be taking you through C. And so for the x, we replace it with a 1, which is 6 times 1 plus 2, and giving us 8.
Okay. Thank you. Then lastly, Julia.
It's the h of 3. X equals 6x plus 2, which is h3, which is 6 times 3 plus 2, giving us 18 plus 2, which is a 20.
Thank you so much. So that's how we are supposed to do those numbers. we are just replacing what you have as your x, replace it into your function. Let me hope now. Okay, I think, okay, no, Mike, I'll give you a chance. Okay, I think, Mike, I'm going to give you a chance, don't worry. Okay, now we can continue to the next number. So, these are how you are supposed to attempt them, and always make sure you write your function and then you substitute in. When there are negatives, please make sure you deal with them very well. Okay. Okay, I think this one I'm going to. Okay. Now this is the next one that I want us to try. I think also we can first try in our books. Is that fine? Is that okay?
Yeah. Yes.
Okay, let's first try.
Okay.
Then we shall do it together. We are trying part A mainly. I want you to first try part A only. Looking through the chat, people are saying B is 5, B is 5, B is, oh, some are saying B is 4, some B5, some B2, B6, B5, B4, B5. Oh. Okay, so I'm saying, okay, some are confused. Okay, we are going to do it. Do we have someone who wants to lead us? Okay. Ndahura, unmute. Ndahura, unmute.
Okay, so in the function, okay, it says fx is equal to, bx squared minus 2. And then in that same function, f like 2 is equal to 18, which means like, okay, so if we put, okay, like let's assume that 2 is in like this first thing. Okay, let's assume 2 is x. So our x is equal to 2, which means when you put it in, when you substitute in, it means that part of b, x squared minus 2 will be equal to 18. So you make an equation and do b x squared minus 2 is equal to 18. And since our x is 2, then we'll put b times 2 squared minus 2 is equal to 18. And then we'll get 4b minus 2 is equal to 18. Then 4b minus 2 plus 2 is equal to 18 plus 2. Yeah, and then you divide 4, like you divide both sides by 4, and then you get b is equal to 5. Yeah.
Thank you so much. Thank you. That is very correct. So, dear members, here they are hiding for us the value of b, meaning that in order for you to proceed with your function, first find out what is b. But they have told you that when you insert, when you input 2 into our function here, the answer you get is 18. So your task is first find out when you put 2 inside the function, what do you get? So you notice that when you put 2 inside, you shall have b times 2 squared minus 2, which is equal to b times 4 minus 2, which gives you 4b minus 2. So this is the function when they have put in 2. Here, an assumption, like take an example. They have told you that when you put 2 inside, like when you put 2 kilograms of sugar inside the machine, you are getting 18 sweets. So they're asking you, what did they do to produce those 18 sweets? So that's why now we are saying that our function, when x is equal to 2, will equal to 18. So that's what she has told us, that now, after reaching this step, you're going to collect like terms. 8, when you look at this negative, it is a negative. And you know that anything to cross the equal sign, the sign changes to positive. So I will say 4b minus 2 plus 2 is equal to 18 plus 2. Therefore, we shall have 4b is equal to 20. So when you reach here, since we are interested in b, we shall go on and divide. So I will divide by 4. I will divide by 4. And therefore, we shall have our b equaling to 5. So that's what we shall get. Okay. So after now obtaining your value, you can go on and first write your function in a fresh way. That my function now is going to be f of x is equal to, where there is b, I put 5. So I'll have 5x squared minus 2. So even you can first prove, you ask yourself, when I put in 2 in this function, do I get 18? So before you conclude, you can even test your answer to ensure that what you are writing is very okay. Yes, now Lion King, 18. Okay, how did we get 18? Okay, I repeat. Now, when you look at the question, they have given us two things. They have given us the question, this one, and they have given us the another stem for the question. Now, this stem is to help you to obtain the value of b, because with 2 unknowns, you cannot be able to obtain the answer. So in order for you to be able to obtain that answer, it means that you must first use this condition that when we put in 2 into this function, into this machine, we get 18. But we are asking ourselves, if you are putting 2 into the machine and you are getting 18, what do you think b is? So get this 2 they are telling us. Remember, this 2 is the one that represents the x, is the one that represents the input. Put it into the machine. So you'll have b times where there is x is where we put that 2. So I'll have 2 squared minus 2 should give us 18. And therefore, when you reach here, do the mathematics. 2 squared means 2 times 2, which is 4. So that's why here we have b times 4 minus 2, which is giving us 4b minus 2 equaling to 18. And then you can continue with the mathematics. Okay. So that's how you do it. So I want you to continue. Let everyone now continue.
Mr. Kaziba,
Yes.
in the chat, this person whose name is Abila Peter, I think it's Priska, she's asking, she has not understood. She has been complaining for some time.
Abila Peter?
Yes, I think she can
Abila,
raise her hand.
now,
Did she ask?
I'm saying Abila doesn't have a microphone, so he's not hearing what we are saying.
Oh, it's okay. It's
Yeah,
okay
so
then.
that is where the problem is. Yes. Okay. Yes. Okay. 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 Let me ask Emily. Emily, unmute. Emily. Emily, unmute.
Yes, teacher.
Yes. Where? From where?
Teacher, on B, on how they substituted the 2 to get the 5.
To get the 5.
Yes.
Did you understand up to this step?
No.
Okay. Okay, keep on. Now, Emily, we say that our f of 2 at 18. So our function f is bx squared minus 2. So we say that when you find f of 2, it means that this 2 inside the brackets is what represents your x. So in your function of f, for you where you find x is where you put 2. Wherever you are seeing x, put this value. Now, when we come to our function is bx squared minus 2. So they have told us that f of 2 is equal to 18. They are telling us that when you put 2 into the machine, the answer you get is 18. But we are asking ourselves, how did they come up with 18? What did the machine do? So our x for this case is 2. So where there is x, I'm going to put 2. So I'll have b times x squared. So x we have said is 2. So I'll say 2 squared minus 2 should give us 18. Is that fine? I don't know. Emily, are you still? Emily, is it okay?
Yes, teacher.
So Emily, you don't mute. You can. So Emily, so we shall have b times, Emily, what is 2 squared?
2 squared is 4.
4 minus 2 is equal to 18. Now you ask, what is b times 4 is the same as?
B4.
B4 of 4b. So mathematically, it is always sounds better always to start with the digit, then the other variable. Minus 2 is equal to
18.
Is that okay?
Yes, teacher.
Take for us the negative to the other side.
4b minus 2 plus 2 is equal to 18 plus 2.
So 4b is equal to?
And 20.
20, So how do we remove that b now?
We divide 4 on both sides.
Okay. So b will equal to? Twenty divided by 4. Hope you are getting 5. Okay. So that's how we do it. So I want you to continue and get part B and part C. So for your function now, after obtaining your function, there is no need to calculate again. So for you now, your function, write it very well. Where there is B, put 5, x squared minus 2. So I'm just looking into the chart to find out what you have for f of 2. F of 2, f of 2, now substitute in that function. Ketra is getting 18, Stencia 18, 18, 18, now to be 18, 18. I think 18 is very okay. Linda, Julius Arnold, good, good, good. Okay. Yes. Those who are finished, we can go to parts as well. Yes. ITEL. ITEL. Yes. Ruth, do you have a question?
Yes, my
Okay.
question is still for part B. Part B, is it necessary for us to rework out using the equation that was given? The function f into brackets x is equal to bx squared minus 2, or we just state the answer because we have been given the other equation that's direct of f into 2 is equal to of 2 is equal to 18.
Okay. Ruth, all of them are correct. All of them are correct. So when you state 18, that is very okay. When you state 18, you can back it with a reason. Yeah, but all of them are very okay. Yes. So here it is 18. It's just here. So, but it was just a form of way to prove that what you have done, the equation you have obtained, the value of B is correct. So that was the intention, that now you are testing whether what you have really got is correct. Okay. Ruth, another question?
No, let me lower my hand.
Okay. So the last one, I'm waiting for part C. Okay, King Fahad, that is okay. Sam Shidin Adams.
Part C, the answer is -2.
Okay, take us through how you have obtained -2.
I substituted the 5 on B and the X. I put, where is X? I put C2 and I got 20.
Really? Remember, your X is 0, not so? So you have 0 squared minus 2. And this is equal to 5 times 0 minus 2. And now, during the, I think it was this year, whereby candidates were making a mistake. Someone could have, I think, when you are panicking, someone wrote 5 times 0 and someone wrote 50 minus 2. And this person ended up losing. So always when you are working out, make sure you are very, very careful. Otherwise, these small mistakes can cost you a lot. So this is 0 minus 2, which will give us a -2. So let me hope that is the answer we have. Just let me know. Are we good to continue? Can we continue now?
Dennis's hand is up.
Dennis, you can tell us.
Sorry. No, it's okay. It's okay. He
Okay.
also needs to have an audio. ITEL, what's your question? Okay.
Hello?
Mm-hmm.
Are you getting me?
Yes.
My mistake, My mistake was multiplying 5 times 0. So I only made a mistake there, so I would apologize for that.
Okay.
But the answer is -2.
Okay. Sorry about that. Okay. These ones, you are going to try them in your free time. Allow me to jump them. This is the one I'm interested in, where I'm bringing in some few words. So I'm going to check out. Let me first mute because I had muted you. Let me first disable that as we try out this also. So this one, I want to test whether people know what we call initial velocity. Can someone raise up the hand and you explain for us? Now we are bringing Atugonza. I saw Atugonza. Okay, Priscilla.
Can you hear me?
Yes, clear.
Initial velocity is the velocity of any moving vehicle at the beginning, which is always 0.
Okay, so what is the value of t for this
T?
case?
0.
0. Okay, good, good. So that was the only trick for this question. So you needed to have that background for physics, that initial velocity means that the particle is just starting to move. So the time t is equal to 0. So find the answer. Otherwise, someone who doesn't have that idea would fail this question. So find the answer. Find the answer. I'm checking the chat. Very good. Laura is saying -9, -9, -9. Very good. Yeah, that is okay. That is very okay. That is okay. Okay. Unless someone is getting challenges, -9. Ndahura, are you getting any challenge? Rodin, are you getting any challenge?
Teacher.
Yes.
So when we're learning physics, like okay, in my school, sometimes like when a teacher talks about initial velocity, like okay, there are times in particular questions where it can be any number. Like let's say, okay, like like initial velocity before deceleration or something like that. So okay, if I got this number, honestly, I wouldn't know because the initial velocity can be anything. So yeah, that's like okay, it's a bit confusing.
Okay, thank you. I'm going to comment. Okay, Esther.
Okay, to try to rectify that, okay, some on the physics question, they used to tell us that a vehicle is already moving with this velocity. So that used to be the initial velocity. So if the vehicle is already moving with a velocity of maybe 50, so like for us, that's when you used to write that as our initial velocity.
Okay, good. Charity Shalom.
Teacher, I have a question.
Yes.
Does the T represent time?
Yes.
So I
T
think
represent.
why the T is equal to 0 is because at initial velocity, the car is just starting to move. So I feel like there is no time covered. Maybe that's why the T is equal to 0.
Wow, perfect. Perfect. Okay. Yeah. Now, Imran, anything you want to add on?
Are you hearing me?
Yes.
According to me, they used to tell us in physics that the initial velocity is got by it is the velocity of any vehicle or anything in motion. By the time they start studying its motion, that is the initial velocity. Then I'm still wondering why you are taking it as 0.
Okay.
That's so.
Okay. Now, I think people are confusing two things. You are confusing initial velocity and you are confusing time. For this, please, those are two different things. For the initial velocity for this question is not 0. What is 0 is the time. I want to let you know that whenever initial velocity is not 0, people were saying that initial velocity is 0. No, what is 0 is the time. The time you start to time something when it is starting to move. Initial velocity, when I use a graph, it can be like this, whereby you have v and you have time. Anything where you have initial velocity, always the time will be 0. Something start, but it doesn't mean the velocity is 0, because your car can start from a given velocity. Let me say 5. It can start from 10. It can start from 0. It can start from negative. So it doesn't matter. But the timing, when they start to time it, is 0, because it is just about to start, or it is just starting to move. So what is 0 is time, not the velocity. So that's why for your velocity, you are getting your answers -9 meters per second. But what is 0 is the time. Okay, let me hope that is okay. Yes. So when you are, the timing you start to count, when you switch on your clock to start timing, you can be in motion, but when you are not timing. But when you start timing is when that is the time we are going to count. So we say you are starting from 0. Take an example. You may find someone walking from Kampala to Jinja, but someone may start his clock when he has reached Mukono. So that time when you start timing is what we say t is equal to 0, and then you count how many minutes you take. Yeah. Okay, we can continue to the next question. Yeah, please don't confuse those two words. Don't confuse velocity. That velocity can be anything. It's not a must that always the velocity is 0. No, it can be anything. It can be negative. It can be positive. But what is 0 is the time. Okay, part B is there. So let's do part B and let's do part C. Do part B and do part C. I tell.
Sir.
Yes.
To me, I knew that V is the final velocity, then U is the initial velocity. So according to the equation, the equation is V of T. So I'm somehow confused. I thought it was going to be U of T. Say that U is the final velocity.
Now, before you don't go off, now one thing you need to know is that when we are representing a function, we can represent it using any letter. So you can find when it is velocity, when we are using even K, when we are using any letter. So the letter used doesn't define it defines the function, what the function we have. So don't always look at those letters and think that it is always supposed to be U. What matters is the value of T, that initially, when you start timing, T is equal to 0. So V can represent final velocity, and when you advance, even you'll find that V is used even to represent any velocity. So those letters are not like, don't take it that always it is V, it is U, it is V, it is U. But those are just, they are used specifically just in physics, but it can be any letter. And in functions, we use any letter of our choice.
Yeah. For me, I saw that we were using that concept from physics.
Okay, yeah. But in physics, you can find someone using V or using any letter. Talima, Rodin?
It's okay. Understood.
Rodin?
Understood.
Okay, fine. Okay, so we are trying. I'm waiting for me. I'm looking. Yes?
Sorry, this is Tarima.
Mr. Kaziba.
Yes, Tarima.
Yes, I was just trying to clarify on the issue of initial velocity. Initially, when I was doing my calculations, I also had the same problem until I did the calculation and realized that I was getting a velocity of -9. That's when I realized that when you said t was 0, you were not talking about the velocity. Initial means beginning, and at the beginning of everything, time will always be 0, even when someone is born. So that is why people were confusing it initially. They thought time was velocity.
Oh, okay. Thank you. Thank you, Rodney. Okay, yes, Ruth. I think people have the answers. Okay.
Yes, before I go to the answers, my other question. In the first place, before we came to the word problems, okay, these ones are called word problems. Before we came to the word problem, this one of a velocity of a particle. Before, we've been working out the numbers, and we had function f into, function of x is equal to bx. We are stating this when we are stating the answer for word problems. We just state that maybe v is equal to 7 meters per second, and then has per second, or we have the v of 4. I don't know if you're getting what I'm saying. Get v into brackets 4, and we have it being equal to 7 meters per second.
It is very okay.
Like we have been doing for the fx, then f into 0, f of 0, sorry, then you get the answer.
Yeah, it is
So
okay.
that's also okay.
Yeah, they're okay. So even this one, someone can write it as v of 0, or someone can write v when t is equal to 0. So what we are hiding, this question, what it was hiding, we didn't want to give you this direct one, because if we give you the direct one, everyone can do it. So this is the concept we are hiding. The same thing here, that instead of giving you v of 10, for us, let us just take that the time is 10 seconds. And then for you, just need to know that it is here. And now when I try to draw this, these are the graphs you find, those who have done. That is a curve. That is a curve you'll find like that. So when I draw it, here, this is the time when it is 0, this is v, and this is t. So at this point is where you have -9. At this point, this is the velocity at -9, and then it goes up into a curve form. Okay, so I think we are there. I want to display the last question for this number. Where is that question? Okay, that is the last question. Now let me ask, I want to ask people, someone to throw more light on part D, because also there is a concept that you need to know. At what time does the particle come to rest? So I'm seeing one hand up. Rodney?
Yes, for us to calculate at what time the particle comes to rest, we have to remember that for any object to be in rest, its velocity is at 0. Its velocity is at 0. So this time we are going to twist the equation a bit. Vt is the final velocity. The function v into brackets t is the final velocity. So what we are going to say is that final velocity we know that this object has when it's at rest is at 0. So Vt will be 0. And we're going to have the equation t squared minus 9, which is 9 meters per second.
Okay.
Is going to be equal to 0.
Perfect.
So after that,
Rodney, is it possible to first give them some few minutes to try, and then you come back?
All right.
Okay. So please take that concept seriously. Yes. When they tell that something is coming to rest, it means that its final velocity is 0. So when you are coming to rest, you are resting. It means that you keep on reducing your velocity up to when it reaches 0. So when you are final at rest, even if it is an accident, at rest v is 0. Yeah. So we are trying that one. Wow, good. Charity is saying 3. Itel is saying 3. Indahura is saying 3. Uh, okay. Okay, so I'm waiting. Are people getting 3? Yeah, I'm seeing some good answers. 3, 3, 3, 3, 3. Wow, 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 wow. Yeah, it is 3. Yes, the keyword was when V is equal to 0. I'm stuck. That is as hello. Is stuck. Yes. Now the keyword is faith. The keyword here is coming to rest. That was the keyword. So let me ask Rodin to take us through.
So, like I was saying, we're going to turn it into an equation. T squared minus 9 is equal to 0. So we shall then have t squared is equal to 0 plus 9, because when the negative 9 changes to the other side of the equal signs, we're going to have it as a positive. So 0 plus 9 is equal to 9. So t squared is equal to 9. And here we shall put square root symbol on every side and have t equal to 3. So we shall have our final time as 3 seconds.
Okay, thank you. Thank you. Anyone who has not understood? Okay, someone is asking, can we draw the graph? Now, when you look at this graph, this is a quadratic graph. And since they have not asked you to draw the graph, you may lose out because they want you to calculate it. Okay. Okay. So that's how we are getting there. Those who have come in late, I think we are really sorry. But the good thing, we are going to have this recording before 7 of today, before 7 today. Okay, I think we are good to start. Kindly let me know. Are we good to continue?
Yes.
Okay.
Yes.
There's some hands up.
Yes.
Sharia, do you have any question?
Yes.
Do you have any question?
Yeah, okay. About number D, I really don't understand.
So, Ruth, have not picked a question.
She didn't understand part B. I request Linda, please mute. Okay, so Sharia, I think, didn't understand part B. I also didn't get her clearly, but I think Sharia, did you say you didn't understand part B, right?
So part B, they told you after 4 seconds, it meaning that your time t is equal to 4. What do? You have your velocity equaling to t squared minus 9. So it means that where there is time, put 4. Where there is t is where you're going to put 4. So I will say v of 4 is equal to 4 squared minus 9. Then you ask yourself, 4 squared means 4 times 4 minus 9, which is 16 minus 9. And then you ask yourself, what is 16 minus 9? Now, the answer you get is the answer we'll have it. So people, I think, got 7. So that's how you had to do it. Okay. I think now we can continue.
She's saying part D.
Part D.
Part D. Because she's not the only one. Even Matthias also has a problem. He says he's asking for a repetition of part D. Then even Sharia herself.
Now, this is our function. They told us that at what time does the particle come to rest? Coming to rest means that you are stopping. It means you have stopped. The journey is coming to rest. And you know that when those who know how to drive, those who can ride bicycles and so on, you know that when you are coming to stop, it means that you must reduce on your speed. So literally velocity means speed. So now when they tell you that you are coming to rest, it means that just imagine you are moving or you are driving or you are riding your bicycle and you see an obstacle. It means you must hold your brakes. And the moment you hold your brakes, it means that your speed is going to reduce. So when you come to rest, it means that you can no longer now move. You are in one position. And when you are in one position, it means there is nothing like movement. Your speed is 0. It has come to 0. So that's why we say that your V will equal to 0 or your final velocity. So where there is V is where you put 0 is equal to t squared minus 9. Now, when you reach here, your task is to find out what time is that. When do you get your t is equal to 0? Imagine you have been moving. You have been moving. At what time do they expect you to stop? So then you work out. So this will be, so in case you want, you can write it like this. T minus 9 is equal to 0. So get this negative 9. Take it this side. So you have t squared minus 9 plus 9 is equal to 0 plus 9. So you get your t squared is equal to 9. Get a square root, get a square root. So your t will equal to 3. So please take note that here we have positive 3 only. So those people who know very that when you have a square root, you can get another answer. For this case, you don't. Why? Time can never be a negative. So that's why you consider positive time. Okay. Now let us proceed.
Okay. As we proceed, take note if your device is techno and you didn't rename, you send your question in the chat plus Brandon so that we can proceed as the teacher also receives them.
Okay.
Otherwise, they have understood.
Okay, this is the last number. I'm interested in you people doing number A, then part B we shall work out together. Yes, I'm interested in you doing part A, and then we continue to composite. The last 15 minutes must be for composite. So do part A, and part A is testing. Do you know how to work out with negatives? That's what it is testing. Okay, so I'm looking the chat to test. Oh, okay. Oppo, your answer. Yes, I'm seeing people were writing some. I don't want to use the word ugly. The answers are okay. Yes, yes, yeah. I'm seeing all the answers are okay. But what is now making them a bit ugly is where you're placing the negative. It's where you're placing the negative. So you need to have a beautiful answer whereby people who are writing decimal points, you are missing out on the accuracy. Whenever you write out a decimal point and the question has not stated so, you miss out on accuracy. I'm seeing now beautiful answers. Okay, good, good. Yeah, at least now the answers are beautiful. Yeah. Now I was saying, I know very well that you have got this part very well. 1 out of x minus 6, and we had h of negative 3, which gave us 1 out of negative 3 minus 6. which is 1 out of -9. The answer is okay, but always mathematically, when you are writing, when you have a negative down, take it up because this negative affects everything. So write it in a beautiful way, like -1 out of 9. This one looks much better because someone who's marking at times even may notice this negative down, much as it is correct. But this is the best way. When you meet a negative down, you can just write it as one number. Then people who are writing to 0.111 something, please and please desist from writing that answer. Unless when the question has told you that write to 2 decimal places, write to this, write to this. But if the question does not ask you, then it means don't commit yourself to writing to decimal points. Leave your answer like this. It is more accurate. But when the question specifies that use the decimal points, write this, then go on. But in case it does not specify, then leave your answer in fraction. It looks much, much more beautiful. Now, part B.
Mr. Kazila.
Yes.
Sorry for interrupting. Sorry for the interruption. I'm requesting you to move to that chat. Is Jerry's answer correct? Have you seen it?
Not
Jerry's answer.
Jerry.
Okay. Going to scroll.
Jerry.
Jerry.
Oh. No.
Just before.
Oh. Okay. Now, Jerry, I'm seeing the answer. The answer, Jerry, I think you are trying to write like this. Yes, Jerry, if so, this one is okay, though it is very okay because this one will still turn as 1 out of -9. So it is also okay for it to write, but avoid writing such answers. Avoid writing such answers unless when the question has asked you to write in index form, then you can write like that. But in case there's not, then do not write that answer. Okay. Now, the next part is asking us, is there a value where h of x does not exist? Now, one thing you need to know is that when they ask you, where does it not exist? It means that mathematically, when do we get those situations where your calculator is giving you an error? Take an example. You cannot, when you place your calculator 3 out of 0, your calculator cannot work it out. Why? Because it is a math error. It does not exist. So a calculator gives you. And therefore, for any fraction, for any function that does not exist, that is in the form of a fraction, it means that the denominator is equal to 0. Whenever they ask you the value that makes that function not exist, it means that this denominator is equal to 0. And therefore, your task is to look out for that value, which will make this denominator equaling to 0. So in other words, when they don't use the word does not exist, they use the word meaningless. Meaningless meaning it does not make sense. So it only happens when your denominator is equal to 0. So for such a case, we shall have you get the whole of your denominator, which is x minus 6 equate to 0. And therefore, you find the value of x. So we shall have plus 6 is equal to 0 plus 6. So x will equal to 6. So the moment you insert in 6 into this function, you are going to find out that your function, you are getting 1 out of 0. And therefore, it means the function is not existing. Kind of let, yes. Or they use that word undefined. Yes, so those words mean the same. Undefined does not exist. It is meaningless. Those are the key words. And at times you need to know how to solve quadratic equations. Yes, at times you're going to find a quadratic equation. And that's what I'll give you in the exercise. You'll find a quadratic equation. So you need to know how to solve. Yes, at Gonza. think I'm not getting Atugonza, Tekino, and Atugonza. Yes.
Excuse me, teacher.
Yes, please.
Teacher, I was requesting for you to pardon on the explanation of part B.
Okay, I'm going to do so. Then 704. Joe, is it Josh or who? That one.
Excuse me, teacher.
Yes. Oh, I'm failing. Ruth, I think I'm failing to get your network. Your network is betraying. 70 something.
Are you getting me now?
Okay.
In the chat, Joanne and Tracy are requesting for you to pardon them. I think even that's what the past participant also wanted, pardon on part B.
Okay. Okay. Let me, yes, Precious.
Excuse me, teacher.
Yes.
As question to ask, or if they tell you to explain afterwards, after getting all this, should I have to explain in words so that it does not exist because the denominator is 0, like there you told us?
Yes.
Do they need all that explanation like in words?
Yeah,
It
they want
carries
you
the
to,
mark.
yeah, they want you to explain. So now your explanation should be that when x is equal to 0, the function or the denominator is equal to 0, which makes the function meaningless. It makes the function does not exist, and you cannot divide by a 0. So you explain.
Okay. Okay, thank you, teacher.
Okay. Now I was saying, allow me to give, let me use this example. Imagine this is what we have. I'm just using this as an example. Now, for this function, it makes sense. However, if we get, let me say, h of 4 and put in this function, we are not saying that up, we shall have our 13 out of 0. So in mathematics, you can never divide anything with a 0. It cannot be divided. And therefore, since it cannot be defined, it means that you are getting an error, or what we are calling the math error. So for such cases where you get math error, it means that that value you have put into your function does not fit in. In other words, they're asking, at times we can, you have seen some functions, or you have seen some machines whereby when you put in something of which is not going, of which it was not manufactured to do, it does not work. So that is the question. That's what the question is asking. They're asking you, not all values will work for the function. There are things you put in and the function will rubbish them. They will not go through the machine. And therefore, one of the numbers for such a case, the number that will not go through the machine is 4, because the function, the machine is going to vomit it. And at which cases does the machine vomit them? It vomits them whenever the denominator or the number down is 0. And therefore, for you to find out which particular number is that, we just get this number in your denominator. You get this function in the denominator, you equate it to 0. So you say x minus 4 is equal to 0. And therefore, my x is equal to 4. So for you, whatever you see does not exist is meaningless. Get everything you have in the denominator, equate to 0. Even if it is x squared, say x squared minus 4 is equal to 0. My x squared will equal to 4. Get a square root, get a square root, meaning that x is equal to 2, x is equal to negative 2. For you, put everything. And for quadratic equations, you'll be getting 2 values. So what matters a lot is that this value you get, which when you put it into that thing, down here you get 0. That's what you call meaningless. Hope it is okay.
Mr. Kaziba, does that mean that if I get my x as 0, that it turns out to be, and that the whole function turns out to be undefined.
Yes, the moment you put in these values, like for this function, when you put in 2, you are going to get down 0. When you put in -2, down you are going to get what? 0. So that means the function cannot move. Those are the values the machine vomits. You put in something, it vomits, or it breaks it.
So is that x -4, does it also give me an undefined function?
Yes, when you put, like in case it's x -4, when you put in 4, it will give you that.
Okay, I've understood.
Okay. Yes. Now, those who are lost, what you need to know is, Abida, your problem is your microphone is off and you cannot just hear something. So that is your problem now. But what matters a lot is that down, for you, the denominator, that value you see down must be, you equate it to 0. However big it is, you might find even numbers. You may find something like this, where there is x squared minus 4x plus 8. And they say at what point, these points, then for some functions, you can easily guess them, but not all functions you can guess. So what do we do mathematically is you equate to 0 and you calculate that value. For some values, you can easily see it, but not all that you can see them. Okay, last one, Tessa and Tekino.
Thank you. I have a question.
Yeah.
After equating that denominator to 0, is it okay if you conclude and say when x is 6, the function is meaningless or does not exist?
Yes, you conclude.
Thank you.
Okay. Then the last one, is it Tekino?
Sorry, sir, I have understood.
Oh, okay. Now I want to just ask the class whether you still have some energy. Let me ask. Just respond. Do we have energy to continue?
Yes.
Yes.
Yes. Up to 6.
Oh.
Yes, yes,
Oh.
yes.
Okay.
Up to 8.
Up to 6. Yes.
Yes.
Okay. Okay. Now what I'm going to do, these numbers I'm leaving them. They are for you, just for your practice. You will do them for your practice. I want to just introduce this concept of composite functions. And once you understand, it will be just enough for us to end. Now, what do we call a composite function? Like the way you hear the word composite, you are composing, you are bringing it together, you are combining. That's what you call a composite function. A composite function means you are combining, like the way we saw how we manufacture sweets. We said that in manufacturing a sweet, you are going to do very many things. Take an example. When you are baking a cake, you make sure in a baking of a cake, very many things are involved. You have to get, is it flour? You get this, you get this. So you combined a lot of things. So in the previous things, we have been dealing with just one thing, one function. So now we are going to combine. What if we have, you have seen those machines, those people who have been to those industries, you have seen a machine whereby someone comes, he puts in something here inside. Something passes through that one, then it goes into the second machine. When it reaches this machine, this thing, it is worked on. Let me say, we put here our maize, because the maize grains. What happens when the maize grains go into the machine? The machine is going to first break them into small, small particles, and then those small particles, they will go through another machine. Another machine breaks them into the flour, like that, like that. So we have those kind of machines that process very many things, very many functions. Like take an example, when you are going to cook food, what are you going to do? You are going to first peel. That is the first function you do. After doing that, you are going to put your thing on firewood. That is the second thing. And then after, you will have your food ready. So those functions, so we are going to ask ourselves, when you peel, that is one function. When you put your food on firewood, on the cook and so on, that is the second function you are doing. So you have seen people who go for those things of marriage, introduction. The person first comes, he introduces. After introduction, they have to go to the church. So there are very many functions that they do perform. So we are going to ask ourselves, how do we combine them for us? But at the end of the day, you have seen people who go for introduction. If they first visit, they go for introduction, they go for church ceremony. But you have also seen people who combined everything at a go. So that's what we are looking for. For us, how shall we combine the introduction? We combined it with the church service on the same day, and we are successful. That's what we call composite functions. So we are going to combine those two weddings at the same time, and we get the same answer. Whether for me, you are working, so at the end of the day, the end results are the same. Whether you have gone for your introduction on 2 different days, at the end of the day, you are married. So that's what you call a composite function. We are going to combine those two things and come up with one thing. Hope we are okay. We continue. How do you write a composite function? A composite function is written in 2 formats. Don't mind about writing. What is important is understanding. How do you write it? This is the first format. At times you find them being written like this, f g of x. We read it as f of g of x. At times, you may find them written like this, f of g of x. So, any of this format, these are the common formats they write them. So when you find any of this one, it means they have combined. So this is the person who has combined the introduction, has combined the conjura. This is the person who has first taken water and has taken food. So we are looking at that combination. So when we talk about a composite function, we shall have 2 functions. So here you are going to find f of g, g of h. You're going to find g of this. So we shall be combining 2 things and we get the same results. Hope we are on the same track. Yes. So that is what we call a composite function. But before I continue, I want to first know whether we are still on the same page, whether people are understanding before we look at an example. Are we understanding, members?
Somehow.
Somehow. Okay. Okay, let me ask members. Members, unmute before we look
I
at.
request your pardon.
Yes.
We are understanding.
We understand.
No, we are not understanding.
Teacher, we understanding.
Yes.
We understand.
No, we are not understanding. Pardon.
Okay. Okay.
Slowly.
Okay.
Teacher, we are understanding.
Okay.
Teacher, we are not understanding and go slowly.
Okay. Okay.
Understanding. We are
Okay.
understanding everything.
Okay, good. So I know. So I'm going to repeat what we call a composite function. So let me write and you see. Now, what I'm saying, I'm just repeating such that we're on the same page. What I'm saying is that take an example. This is my machine. I have another machine here. And lastly, so I have this machine which adds a 2. I have this machine which multiplies a 2. And here I have my input and this is my output. So let me ask people, our input is 5. Tell me in the chat, what is our output? Yeah. Use the chat, type quickly and we see. Quick math. So type in the chat. Good. Perfect. So I think the 14 you are doing, this is your first function, addition. The second function is multiplication. So this one can be f of x. This one can be g of x. So you are performing 2 functions, f and g. So that's what we call. Now, when you combine F and G is what we call a composite function. So in other words, we are dealing with double machines, things that do double. It's like I was using a real life example and I was telling you is that, okay, let me leave that. So that is okay. So that's what we call a composite function. Yes, Atugonza.
Teacher.
Yes.
What if you want to go back to the input? Is there a formula for that also?
Yes, there is a formula. Yes. Now that formula to go back is what we shall be calling the inverse. Yes. So we shall look at it. So this is what we call the composite function. So, but now what is going to be a composite? Our composite is going to be that machine. Is going to be that machine that can combine the two. That instead of you doing them in breaks, you first do this one. I do this one. You want this one, whereby you put in your thing, you put in 5, and you are able to get your answers as what? The answer is what? 5 plus 2 is 14. So that is the machine we want. We want a machine whereby when you put in 5, your answer is what? Is 14. So this one is what we call a composite. You are combining at a go. Instead of you working in step 1, step 2, now we want to do what? Combine. Let me know whether now we are on the same page, what we call composite. Are we on the same page?
Yes, teacher.
Yes,
teacher.
Okay. Okay.
Teacher, your hand is up.
Yes, teacher.
Okay. We're on the same page, yeah?
Yes, teacher, we understand.
Okay. We are going to agree. We are going to agree. I'm going to do one example. Now, this is what is going to happen. Here, pay attention. Pay attention. Pay attention. We have f of x equaling to x plus 2. I have g of x equaling to 6 minus 2x. And like I've told you, here they can tell you find f g of x. Now, this is where you need to pay attention. The moment you understand this, I'm going to be the happiest. Now, this one, what does it mean? F g of x. Now, when we are working out this function, please take note. F g of x means you have your f, you have g of x. Now, in this function, it means that you are going to get g of x and place it in f. That is the meaning. So I'm writing, I'll have, what is my g of x? My g of x is 6 minus 2x. So I'm going to have f into 6 minus 2x. Now we are feeding into the machine. So we are feeding in this function because we want to combine them such that we have one thing. Now, after doing so, you ask yourself, this is f, and we have put g inside f. F is like the bigger thing. So these smaller ones, you put them inside. So always, what is inside is what you first put into what is outside. So always, in case it is h of g, this g is what you put into h. In case it is f of g, this g is what you put into f. In case it is h of m, this m is what you put into h. Members, just type in the chat that concept is okay, of putting in. Is that thing of putting in okay? Okay. Okay, good. Everyone is saying at least that is okay. Ata P. Atapi, tops, anything? Okay, good. Yeah. So always the first one on your right is what you put into your left. Now, after putting, in other words, let me even draw. It means this is f of x and g of x is what is you put inside. So you get your g of x, put it inside of f. Please take note that concept is very, very crucial. Now we continue. Now, what does it mean? It means that after doing so, I'm going to go to where f is. What is my f? My function of f is this one. Now, the whole of this function of g of x, the whole of this function is representing x. So I'll have my f, which is this. So our function of f is, our function of f of x is equal to x plus 2. So it means that in this new function of f, where we have x, we are going to replace it with the whole of this. So we bring this one, we feed it here. So we shall come and say f g of x will equal to, where there is x in f, we put the whole of the function of g. So I'll have the function of g, which was 6 minus 2x here, then plus 2. I know we might be leaving some people. First type in the chat whether that one is okay. Type in the chat whether we are on the same page. Okay, I've got Joy. Okay. Not yet, not okay, not okay. Pardon. I'm going to pardon. I'll come back. I use this space. Let me use this space. We are saying f of g of x, we have said that in g, we put it into f. But what was our f doing? When you look at the function of f, f was saying x plus 2. Now, in the function of f, whenever there is x, we put this new function of g. So I will come, I say, in f, where there is x, I put the new function of g of x. So it becomes g of x plus 2. So we are replacing the values of x in this first function of f into with g of x. So our g of x is 6 minus 2x. So that's why we say 6 minus 2x plus 2. So this new function of g of x, put everything the way it is into f. But where do you put it? You put it wherever you find x is where you put that function. Now, I want to tell you, when you reach here, collect like terms. I have 6, I have that 2. So I'll say 6 plus 2 minus 2x, which will give me 8 minus 2x. I want to let you know that this is your answer. That is your answer. Once you get that, you have obtained it right. Let me first pick some few questions. 2 only. Yes, at Gonza.
Teacher, don't you like, my question is, don't we like simplify the answer?
Oh, now that one is, you can leave it at that point. It is already simplified. No need for you to factorize, do what, you can leave it like that.
Okay, teacher, thank you.
Yes, unless when they have told you. Bakita.
Yes, teacher, I would like to ask, so you were saying when like the f of x equals to x plus 2, then the other side there is g of x equals to 6 minus 2x. So we shall get the 6 minus 2x to replace the x in f of x equals to x
Yes.
plus 2. Okay, thank you.
Okay, yes, Ruth. Ruth? Oh, Ruth, are we losing you? Okay. I think.
teacher, for me, unfortunately, I'm not getting it because,
Hmm.
okay, are you hearing me?
Yes, you are clear. Oh, okay. Ruth,
Are you hearing me?
yes, continue, Ruth. I'm getting you.
Okay, I was asking in the previous slide. My question is, why can't we not use
Why can't we use?
in the previous slide? Are you hearing me?
Yeah. Yes, continue.
In the previous slide, why don't we just use, apart from that law you've shown us, why don't we have 6 minus 2x, then we just, I don't know how I can say it, instead of bracketing 6 minus 2x, we instead bracket I think I'm even confused with the whole thing. I don't know how I can bring out what's on my mind.
Okay, let us first do this one and we see. Take an example. I'm using this. We are having g of x. So like we have said that, what are we having? That you have your machine. This is our machine, which is g of x. Now this machine of ours of gx, we are going to get it and put it into f of x, such that at the end of the day, we can be able to get fg of x. So what do? Our g of x, this is the first thing we put into f. What was our g of x? Our g of x is 3x plus 2. Now, we are feeding this one into f. But what is our f? Our f is x plus 2. So when we are feeding it into where there is x is where we put the whole of this, the answer we have obtained from g of x. And yet for this one, our answer we are obtaining still remains this because we don't know the x. So I'm going to get the whole of this. I put it inside here. So when I come to f, where there is x is where I put this. So in other words, I'll have my f of x now equaling to g of x plus 2. I'm replacing it with x. But what is my g of x is 3x plus 2. So I say 3x plus 2 plus 2, which will give me 3x plus 4. So that is now my fg of x. I don't know whether Ruth will be okay now. Ruth, is that fine?
Yes, I've understood now. Thank you.
Okay.
Yes.
Okay. What about the rest? It is now can't. Okay. I'm repeating. We are going to do another one up to when everyone has understood. Ruth, unmute for me, Aida. Ruth, are you unmuting Aida?
Yes, I have.
I did not
Aida, please unmute.
Teacher,
Yes, Aida? Yes.
I did not get the middle box like gx.
Okay. Don't mute. Now, Aida, we have said our first number is g of x. So that is the first machine, which is g of x. Now this g of x, you are going to put it into f such that you come up with fg of x. But what is our x? G of x. G of x is this one, 2x plus 3. Now, the whole of this function, you have to put it into f because f is like the bigger one, is like the mother. So you put everything of g into f. So when you come into f, remember what do we always substitute? We always substitute for x. So I'll come, my g of x, I put it into f. So when I put it into f, I come into the f. Where there is x is where I'm going to put g. So what is my f? My f of x is x minus 1. So the position where there is x is where I put that g of x. So I'll have g of x minus 1. So I just go back, I look out for what is my g of x, it is this. So I say 2x plus 3 minus 1. Then you can simplify. I don't know whether either we are together now. Ida, are we together? Ida,
we don't reduce.
yes? No, you reduce.
Did you say we don't reduce?
We reduce. It is.
I've understood. Thank you.
Okay. Now, I cannot confirm that everyone has understood until when we get this answer correct. F of x is equal to x plus 3. G of x is equal to 2x plus 5. Find for me f g of x. Once I get 25 answers in the chat that are correct, I will know that at least we are somewhere. Let everyone first try on your own. Try small, and we see. When to look in the chat, try. Make sure you don't make any error. Should I look in the chat? I'm looking in the chat. I'm praying that I don't get differing answers. 2x plus 8, 2x plus 8, 2x plus 8, 2x plus 8. Oh. Mary. It is only Mary. Mary 2x. Yeah. This is good. This is good. Thank you, people. Thank you. Any question? Atugonza? Yes. You are? You are getting?
8 plus 2x.
Okay. Okay. Hope this is how you have done it. You have said f, and your g of x is 2x plus 5. So you come into f, where there is x, you put the whole of this. So I'll have 2x plus 5, then plus 3.
Plus 3.
Which gives you 2x plus 8. Members, try for me this one now, and we go. Try for me gf of x. Be careful. That one was f. Now we are trying gf. Sharia.
Okay, teacher, thanks for the lesson, but I was requesting that after this, you can please be saying the slide for the questions you're supposed to try.
Yeah, I'm going to send immediately, but we better end. I don't know. Electricity has gone in our ends. Yeah, so I have about 22 minutes. to be off. So I want us to use just 3 minutes. Then I send that work immediately. This one is a bit tricky, but I know you're very bright people. We are going to get the answer. I've started seeing x plus 8, x plus 8. Now, members, you need to be very careful when you are opening brackets. 2x plus 11. Some answers are coming. Yeah. Okay, that is good. Thank you. Let us see now, gf of x. So here we said we shall say g, then we put f, which is x plus 3. Now we go into our function of g, and we put, where there is x, we put x plus 3. So I'll have 2, in fact, let me use another color to show you that now we are putting x plus 3. And then I can go back to my color and I put plus 5. So when you open very well, 2 multiplies this, so you get 2x. This 2 multiplies the 3, so you get 6 plus 5, which gives us 2x plus 11. Are we there? Yeah. Those who are getting 8, you forgot something. Just check out, but 2x plus 11 is very, very fine. Members, don't you think this is enough for today? I don't want to break you. I want you to have some rest. I'm going to share this. I'm going to share the PowerPoint. I'm going to share it in the group. I think you can give me about when I settle. I'm going to share it. There are some few numbers. Next time when we come, don't mind. We shall also go through again. So there are some few numbers there you can try. In fact, why don't you take this screenshot? Oh, okay. Do you want to take a screenshot? You take. And then you try out. I'm interested in you trying out at least one number. It will be very good. Are you taking? Oh, we better. Okay. Allow me, because I think I'm going off. I will share it. I will share it when power is back. Thank you so much for attending. Thank you so much for being so good. So let's meet tomorrow for other lessons. Let me wish you a good day and a good evening. Bye. Bye, everyone.
Hi, teacher. We love you so much. Thank you for the wonderful lesson.
So much. Love you so much.
Wonderful work, teacher.
Bye.
Bye.
Bye.